How do? My name is Andrew Hancock and I am a VMware technical architect from Yorkshire in the United Kingdom. I have worked with VMware since their birth in 1998, so that's been a quarter of a century now. I've been working with the VMware product catalogue. Some of my close friends say if you cut Andy in half, it reads VMware like a stick of rock from Blackpool Pleasure Beach. I have now written over 130 articles and recorded over 30 hours of VMware vSphere 7 and 8 videos for Experts Exchange, and received 40 Expert Exchange awards over the last 11 years working with the Expert Exchange community. I am currently the overall #1 point earner in the Hall of Fame. I am honoured to have been accepted into the VMware vExpert program since 2011, and I'm currently a VMware vExpert Pro for the last 4 years.
Welcome to Hancock's VMware Half Hour. And in today's video, we're going to try and repair a bug which sadly hasn't been fixed and is the sort of kind of bane of my life really, with ESXi 7.0 ARM. And the bug doesn't actually exist in the VMware ESXi 7 ARM code. The bug, I understand, exists in the UEFI implementation for the Raspberry Pi 4, which is documented, and I believe that there probably is a PR on GitHub that's been open for this for a very long time, but it still isn't fixed. And I can easily demonstrate what the bug is. I've written previous articles on how to install and configure VMware vSphere Hypervisor 7, ESXi 7 ARM on a Raspberry Pi. I'll leave these in the description. And also how to configure the Raspberry Pi to boot from an iSCSI LUN. And in the lab here, we have a cluster of Raspberry Pis, Raspberry Pi 4s, with a PoE header. So these are powered by PoE, and they also boot from an iSCSI LUN as well. And some of them have failed, and they quite regularly do. And it's a simple fix, and we're going to go over that very simple fix today, and hopefully I can demonstrate the problem, the fault, and I can show you how to quickly remedy it. So I've got a PuTTY connection, an SSH connection into my Synology NAS. Which is running the iSCSI target that the Raspberry Pi 4 boots from. So we can actually basically see that there is networking, and it does reach out and try to connect to the iSCSI LUN, and it does actually successfully log in to the iSCSI LUN. But then the UEFI code actually breaks and causes a synchronization problem. So without further ado, I'm going to power up the Raspberry Pi via PoE. So let me just turn on. Okay, so that's the HDMI output of the Raspberry Pi. I'm just actually going to apply a PoE change to my Ubiquity hubs here in the lab, and I'm just having a look up here because I should see a red light come on, but it does take a few seconds really for things to work. There we go. Okay, so the Raspberry Pi is now booting. Everybody would recognize that lovely Raspberry Pi screen. If you look here carefully in the tail logs of the Synology server, you will see that there is actually a connection to the LUN. There we go. There it is. iSCSI login. And not quite sure whether you can see that. I'm sure you can. That we then get a synchronous exception, etc., etc. And that's it. It's busted. It's broke. Now, how we fix this is by taking a particular file, which I believe the corruption occurs in, and we actually swap it with the file from the original build. So I'm going to basically I'm going to power off this Raspberry Pi, apply change off. We should see that go off shortly. Then what I'm going to do, I'm going to take the micro SD card out of the Raspberry Pi. I'm going to put it in this little device. I'm going to put it in this little doohickey thing I've got here on my desktop, and we can have a little look at the files. So I'm just going to pause this a minute. Okay, so I've successfully managed to get the micro SD card out of the Raspberry Pi, which is a little bit of a chore in itself because I've got fat fingers, and I've had to use a pair of scissors to pull it out. Anyway, so that micro SD card is in this little doohickey in a converter, and we can currently see our H drive here is UEFI ESXi 0.0.1, and the problem is with the file RPi_EFI.FD. So I'm going to delete that one. It's corrupted. Like you can see there, it says 0 bytes. I've got a backup of the file. In fact, actually, I've got a backup of all these ESXi SD cards, actually, if I need to. But we're just going to replace the file. So I'm going to copy the file. I'm going to click paste. Big X out of that. And what I'm going to do, I'm going to remove it from the doohickey device and put it back into the Raspberry Pi and power it up. Unfortunately, it does require you to go back and set up all the configuration again in the BIOS, which is a bit of a pain. So I'll go through that, and I'll give you some tips along the way as to how we do that as well. But that's just a little bit laborious, and I'll have to plug a keyboard into the Raspberry Pi device. So I'm just going to pause while I put the micro SD card back into the Raspberry Pi a moment. Okay, so I made the screen a little bit bigger because as the HDMI console's patched into this machine, it may make it a little bit easier for me to actually basically see what is actually on the screen. So the fiddly little micro SD card is plugged back into the Raspberry Pi, hopefully. It is a little bit fiddly, as I said, fat fingers, and the case is the cluster case that I'm using is very small, and it's right up against the shelf, so there's not a lot of purchase really to get the card in. Okay, so I'm going to power on the Raspberry Pi again through a PoE. So hopefully we should see something eventually appear. I've now got a keyboard plugged in. I'm hoping, I've just noticed that keyboard is not plugged in to that Raspberry Pi, so this isn't going to do much. But you can see this time that we've actually got the escape set up F1 shell and enter the boot, and it's obviously starting to PXE over IPv4, which it probably will actually. Maybe. Okay, hang on, just pause. I'm going to have to go and, yeah. So it is actually going to try and boot via PXE, because we actually install ESXi on the Raspberry Pi clusters actually using PXE. So that's all working, and networking is working, but obviously we need to set up the iSCSI LUN, etc. And ESXi is actually already installed on the iSCSI LUN, so all we've really got to do is just set up the configuration required for it to basically boot from LUN, which is not actually doing at the moment in the config there. So I'm just going to have to disappear around the back, and I'm going to have to unplug myself from the video suite here, and just plug that cable in. Just for a moment. Okay, cables, and more cables. Okay, well, it does actually give me an opportunity to actually explain why we've got a lovely pink screen there. And quite simply, ESXi ARM requires 8 gig. It can run in 4, but there is an option that we need to enable on the Raspberry Pi to actually get it to boot. So now I've actually basically got a USB device keyboard plugged in. I'm just going to recycle power on that PoE port. And hopefully this time I will be able to I'm pressing escape, hopefully so that it actually basically gets me to the setup. Okay, and there we are at the setup quite nicely. Okay, so the first thing we need to do is we need to go to Device Manager, and we need to change the Raspberry Pi configuration. Advanced configuration. Such a long time since I've done this. Okay, limit RAM to 3 gig, and the answer is disabled. And this is actually specified originally in the original document that I wrote, which I probably should follow actually, really, to be honest with you. Yeah, there we go. Raspberry Pi configuration, advanced configuration, and we need to set that to disable. Press F10 and yes to save and restart. And this is really some of the problems that I've actually basically had, which do happen, you know, even when you're actually basically configuring the UEFI configuration from within the BIOS here. I've actually basically seen messages where it basically comes up with this synchronization error and corrupts this file for whatever reason. So it does happen. But this is a tech preview. It's not a production product. So these are the sort of kind of things really that we can actually expect. So I'm going to select reset, and I'm going to get ready to bash escape again, and we'll go into the BIOS setup, CMOS setup as we used to call it. Okay, the keen eye amongst you will have noticed immediately that if you look back at the video, the previous screen actually basically turned around and showed us that we had about 4 gig available, and now if you actually basically look, it turns around and says 8192 megabytes available. Okay, so the next thing that we need to do in the lab here, we are booting from iSCSI. So I need to set up the iSCSI initiator name, and I need to set up the LUN, and that's about it, because we're actually basically using DHCP to serve not only the IP information for this particular machine, this Raspberry Pi, but we're also using DHCP to serve the LUN information as well to the device to make setup easier. So Device Manager, iSCSI configuration, and this is where we enter our iSCSI initiator name. And I'm gonna oh, I wonder why I was getting a lot of gobbledygook appearing on the screen here. It's because this keyboard is resting on this keyboard. I know what I'm going to do. Just going to move this keyboard out of the way, as it's Bluetooth, and my Bluetooth seems to be working well for me at the moment. Okay, so I'd love to do a copy and paste from this SSH screen here into this screen here, but that's not going to work, is it? Okay, so as I said, I'm cheating because I'm actually basically looking at the initiator name that I created for this Raspberry Pi. And the way in the lab here, we've actually basically specifically granted access to specific initiator names to specific LUNs via ACLs or mapping on the Synology NAS. So I'm just reading what I can see on the on my other screen here, which is basically the tailed putty connection that we were looking at before. So I'm just going to have a little look. IQN-2022-10.uk.co consultants Cyrus ESXi 0.0.1.arm. Okay, so that's the IQN that's done. Now, this is where in the past, when I've actually basically started to meddle with the iSCSI initiator configuration, is where it usually breaks with this synchronized exception error. And I don't know why. I'm not quite sure whether or not that it's the order that I'm doing things. So I'm just going to click text to save, and I'm going to add an attempt. So I'm going to enable iSCSI, Internet Protocol RPi4. I'm not going to change any of those, but I'm going to enable DHCP. I'm going to enable DHCP for the target. We're not using any CHAP. I don't think we are. We'll go for it. I'm going to press F10. I'm going to say, I don't know what. Save, yeah, okay. So the save changes is there, not F10. So once you've oh, okay. So now it's actually jumped to, okay, so this is attempt 1, not attempt 2. So enable DHCP, enable that, no authentication, and we're going to click save changes. And then I'm going to hit F10. I'm going to save changes there. So my iSCSI configuration is complete. Although I don't know why that says that went back to, maybe I miskeyed or something there. So let's just say save changes. Okay, temp 1, iSCSI mode enabled. We look good. There. Escape. Escape. Okay, now I can, maybe what we'll do now, I'll just shrink that a little bit. Now that I've actually basically done that configuration, when I hit reset here, I can usually see if the configuration is actually correct, because as part of the UEFI boot, it does do a quick login and close to the iSCSI LUN. So if I see that come through now, if I just move that over here, if we actually basically see a login come through, okay, looks like there was a login there. So I'm just going to basically going to expand that so I can see again. I just want to go back and have a little look, see whether or not that. Okay, there was a. I didn't actually see a login. Saw a target core close. Okay, I must have missed the login because there was a close here. But one of the things that does actually give it away as to whether or not that you have actually got proper iSCSI configuration, and there is a LUN available now, is if we look at the boot maintenance manager and we look at the boot options and we change the boot order, normally we can see that we've got an iSCSI LUN there, and we don't. So for some strange reason, it's not picked up. It's not picked up the iSCSI LUN. So let's just go back to the device manager. Let's go back to the iSCSI configuration. Let's go back to the attempt. So it's picked up the IP address, target information. That looks okay, but I didn't see a login. I did not see, as I said to you before, I was looking through the logs. 1324. Okay, hang on. What's the date on this? Okay. 19th of August, 1324. iSCSI login. So there was a login to it. But it actually basically gave me an error message about target core detected non-existent LUN access 4. Okay, just let me put this on pause. I'm going to go and scratch my head. I'm going to go and look and I'm sure I didn't enable chat. Just one moment. Okay, I think I've spotted it. In fact, the IQN was wrong. My dodgy eyesight. The IQN name, initiator name, is IQN.202.10.uk.co.consultants-Cyrus, and it's a colon ESXi 0.0.1 ARM. It's not a dot. So I'll just go back here in our config, put a colon, and then do F10, save. Just go back, escape, and do a reset. So that's what the iSCSI logs was actually telling me. iSCSI target core, iSCSI detected non-existent LUN access for 0x000. So hopefully now I'm going to be able to see a login, but I'm going to press escape so I can actually basically get into the config. Okay, so I saw a config there this time. I saw a login to the LUN this time, correctly. I then got another message that said target core iSCSI expected transfer length 260 does not match SCSI CDB length 245 for SAM opcode, which is normal. So hopefully this time when I actually basically look at the boot manager, can you see now that I've actually basically got the UEFI Synology iSCSI storage. So the iSCSI side is set up in the UEFI BIOS correctly. That's actually communicating to the LUN. So the only thing I need to do now is, using the boot maintenance manager, is to basically change the boot options. So I'm going to change the boot order, and I'm going to move the SCSI UEFI Synology LUN up to the top. Okay, so I'm now going to commit, change, and exit. I'm going to press F10 to save. I'm just going to go back and look at the boot options. The boot order is correct. UEFI Synology SCSI LUN is correct. And I'm now basically going to do a reset. And hopefully, fingers crossed, this time we're going to boot. There is a slight pause, a worrying pause, but I'm again looking at the tailed logs here to actually basically see that I get a iSCSI login. Okay, so there's the iSCSI login. There's the normal sort of kind of boot thing, and then we should start to see that it's actually basically bootstrapping, booting now from the iSCSI LUN correctly. Okay, so that's all really I wanted to show you in this particular video, is how we can repair that Raspberry Pi 4 boot issue using ESXi ARM. And that is specific really to whether or not you're booting from NVMe, or you're booting from SD, or you're booting from a USB flash drive, or you're booting from local disk. The same synchronization error seems to occur in the UEFI bootloader. It gets corrupted, it writes back to that file, and basically, as you saw, basically creates a 0-byte file, and that's it then, game over. Your ESXi ARM is broken. So I'm going to go off now, and I'm going to go off and check the rest of my cluster. And what actually basically drew me to this to start with really is that I actually basically noticed that none of my Raspberry Pis were responding correctly in the cluster. And if I just turn off that, and we actually basically have a little look at the logs from the Synology NAS, you will see there that we've got you can sort of kind of tell really if things have gone wrong, because you get a login at boot from the UEFI to the iSCSI target, and then you get an iSCSI close, but then later on you get another iSCSI login again when the drivers are loading up on the ESXi ARM. So there was the first login there at boot time, then we had the close, now we've got another login there. Now I did actually basically power on another Raspberry Pi in the cluster here to see, and that's what drew me to the fact that the initiator name was a colon, not a dot. And it looks like ESXi 002 ARM is busted as well, because that one powered on. I got a login and I got a close, but I didn't get a login again. So again, I think they're probably all broken in the cluster. It's a little bit of a pain, but it doesn't take much to fix them. Anyway, so thanks so much for watching this video. Please endorse it, thumbs up it, subscribe, and come back for some more videos in the Hancock's VMware Half Hour series. All the best now. Thanks so much, and goodbye.